Hello my dear students, welcome everyone to India's first animated live tuition. I welcome all of you to 90 plus my tuition app family. So everyone get ready over there for a brand new session. We were discussing the concepts of distance time graph, right? So we have started the concept of graphical representation of motion. We have discussed the distance time graph already, so we are going to discuss about the velocity time graphs today. I hope all of you have revised the concepts of distance time graphs. So please do check out what we have learned in the previous session. Please do have a quick look in the regarding the concepts which we have already covered till now. Yes, please unmute Tirtha. Hi Tirtha. Tirtha is very busy fighting with a sibling, I guess. Hi Tirtha.
Hi sir.
Who is disturbing you over there?
My younger sister.
Younger sister. So are you gonna fight with her till the end of session, or are you gonna come into a compromise by this time?
Yes sir.
You'll compromise or you'll keep fighting? What are your thoughts?
Compromise.
You'll compromise, right? So elder sister or younger sister? Younger sister or elder sister? Younger or elder? Younger or elder?
Younger.
Younger, right? So you can make her understand. You are on a session. You are learning something. You need to be a little bit serious, right? Imagine.
Yes sir.
Yeah, fine. Fine. I hope you understand. One final warning. Got it? Tirtha is like, yeah, giggling. Fine, sir, I'll keep giggling all throughout the session. Don't jiggle over there. Yes, unmute Abhinav. Hi, Abhinav. In the middle. Yes. Hi, Abhinav. Are you there? Yes. Marine ma'am. Yes.
Hi sir.
So, Abhinav, have revised the concepts which you have learned till now.
Yes sir.
You did? Fine. So regarding distance time graph, which particular variable will take in the x-axis?
Time.
Will take time in the x-axis, right? Why time in the x-axis? What is the reason for it? Yes, what is the reason for it? Go for it. Let me know. Why are we taking the time in the x-axis? What is the reason for it? Please do let me know. Think about it. I told you guys which variable to take in the x-axis, which variable to take in the y-axis. Yes, please unmute Chris. Christo, Abhirami, lot of my students wants to answer. Yes, Chris.
The time is taken in the x-axis because it is not depending for anyone, and distance is taken on the y-axis.
Distance is taken on the y-axis since it is dependent, and time is something which is an independent variable. So yes, please do unmute Abhirami on top fourth. Yes, on in that ID itself fourth one. On top fourth one. 1, 2, 3, 4. Yes, 3. Hi Abhirami, are you there?
Yes sir. Can you hear me?
Yeah, I can hear you. So what's there in the background? Do you use a Polaroid or something?
Yes.
Okay, you keep your memorable pictures captured over there, fancy background, fine, very good. So Abhirami, do let me know, why are we considering time and distance in x and y axis?
We are taking time in the x-axis because it's an independent quantity.
Time is an independent variable, so that is why we are considering it in the x-axis or the horizontal axis. Then what about the distance? Distance is dependent on the time consumed, right? So it is a dependent variable. Dependent variables will take in the vertical axis or the y-axis. Fine. Got it, Abhirami? You know it already, right? Fine.
Yes.
Rami is like, I knew it. I was a bit confused. Now it's clear. No confusion, right? Yeah. Rajit, please do inform our admin team or else you can't leave. You have to inform our admin team. Don't just take permission during the session, sir. I have exams tomorrow, can I leave? Then why have you joined here? To take permission, you can inform the admin team. Yes, unmute. Who was that?
Ayman.
Ayman, yes, Ayman. You want to answer something or you have a query?
No, sir. So, like, I just wanted to ask something.
Go for it.
So, a graphical representation of motion are so like we have to solve questions like based on the slope, right?
Yes.
So, like, our teacher like taught it in a different way. She said, and like that's why I think I'll be confused.
That's why you were confused. So regarding slope, she taught you some numerical problems or what?
No, sir. She like when we make a slope, right? We get a shape under the
Yes.
slope.
Yes.
And
So
then
she will
according
take
to
the
that-
area of it.
Yeah, she'll take the area of it.
Yeah, using that you can get, because if you take the area, you'll get the value of hypotenuse, right? If you're taking a right angle triangle, if you're getting a right angle triangle, you'll get the value of hypotenuse of it. So that'll be the slope of the graph. And for example, if you are getting any other type of graph, either you will be calculating using two values, you can calculate the third side, right? So using the Pythagoras theorem, you can get the length of the third side, so that using that particular slope value, you can find out the velocity term from the distance time graph. Clear, Ayman?
Yes, sir.
Yeah. So what we'll be doing is, first we'll discuss the concept, first we'll make the concepts thorough, then we'll go ahead with the problems or the numericals related to the graphical representation of motion. Is that clear, Ayman? Ayman? Yeah, fine. So don't worry about the numericals, we'll be solving it, we'll be checking it out. So for the time being, what we'll be doing, we'll be getting the concepts well. Once you are thorough with the concepts, numericals will be very easy. We'll be doing the same as in the case of equations of motion. So in the case of equations of motion, you guys were lucky enough that you guys doesn't have to learn it using graph. You guys doesn't have to learn it using the by following the derivations and all. You guys can just directly memorize the equations and you can apply it directly. But in the case of graphs, we need to learn the basics first. Then only you can apply it to the numericals. You should know how we're considering the slope, why are we considering the distance in the y-axis, why are we taking the time in the x-axis. All these concepts should be there in your mind. Fine. So the distance time graph we have already discussed, the concept we have checked out. Now we are gonna go ahead with velocity time graph. So in the meantime, we'll have a quick look regarding the distance time graph. In the distance time graph, the distance is taken on the y-axis and the time is taken on the x-axis. Distance in the y-axis and time in the x-axis. So please don't forget it. Now, distance time graph for uniform speed will be a straight line, right? When an object travels equal distances in equal intervals of time, what will happen? The distance time graph will be a straight line like this, whereas where the distance will be considered over here and the time will be considered over here in the x-axis. For uniform speed, a graph of distance traveled against time is a straight line for sure. We have checked it out already. Don't get confused with S1, S2, T1 and T2. We are just considering two time intervals, so that is marked as T1 and T2, and we are considering two distance values, that is, they are marked as S1 and S2. You will get to know about this, you will have a better clarity about this when we solve some numerical problems related to the distance time graph. Even though it's not that important, somehow you have to solve some numericals, then only you'll have a clarity. Got it? So it is important. That is why, as Ayman mentioned, all these concepts might have discussed in your school using numericals. Why? Because if you solve some numericals regarding graphs, you will have a better clarity of how to plot the graph. How will we get the graph for distance time with respect to uniform speed or uniform motion? So also the basic concepts or basic attributes should be there in your mind, such as the slope of the distance time graph gives the velocity of a body. So if you don't know this, how will you find out the slope, or what is the point of finding out the slope? You should know, if you are finding out the slope of the distance time graph, it will give velocity for sure. Yes, unmute Rishikesh. What's your doubt, Rishikesh? Please do raise your hands to say, sir, I have this doubt. What's your doubt, Rishikesh? Yes, unmute Rishikesh, ma'am.
Some network issues.
Yes, Rishikesh, you have some network issue, I guess. Marin ma'am is our support tutor today, guys. So Marin ma'am is trying to unmute Rishikesh, but Rishikesh is stuck, I guess. He do have some network issues. Fine. So unmute Neha Das. Hi, Neha.
Hi sir, how are you?
Yeah, I'm good, but not really. A little bit tired. Can you feel that on my face?
No.
Not at all, right? Sonia is like, "Yeah, you don't look tired, but don't lie. Actually, I'm so energetic just because you guys give me some positive energy. Everyone is smiling. Yes, sir, we have revised. Let's go ahead. That positive energy will reflect on my face. So whatever happens over here, I'll be very happy to go ahead with your sessions. So Neha, what's your doubt? Why you have hand raised?
So I remember last class I asked you distance time graph will give speed or velocity.
Yeah, yes, I do
Velocity,
remember.
right?
Yeah.
Yeah. So like in my school, my physics teacher, I asked her the same question and she was like, distance time graph will only give you speed. That is another graph known as displacement time graph.
So for
So now I'm
example,
really confused
okay.
if I have to write velocity or speed because you're telling it's velocity and she's like it's speed.
Got it. The only thing is, so as I've explained in the previous session, did you understand it? The thing is,
Yeah.
if we are considering the distance time graph, the object will have a displacement from one point to another, right? Even so, for example, consider this particular graph. So, when an object is covering a particular distance from this point to this point, is it actually displaced from one point to the other to another with a different path or a straight path? What do you think? Will it cover the shortest path? If it's for uniform speed, it will cover the shortest path, right? So in this case, for example, in the ideal case, always the distance and displacement will be equal, right? Will be equal. And in this case, if you ask me, should I take the displacement time graph or the distance time graph to get the velocity? Obviously, even if you, with respect to the equation, if you consider distance divided by time, it will be speed. If you consider the equation of velocity, displacement divided by time will be velocity. But in the case of a distance time graph, when an object moves in a straight path, distance will be equal to displacement, right? So the object actually gets displaced from one point to another. So obviously, theoretically, if you ask me, the case of a distance time graph or displacement time graph for uniform speed, end of the day, we can consider it as velocity. And also, there will be certain confusions arising when you solve numericals. So I'll tell you that. That is, have you seen some questions like the speed acquired, Neha? What will be the final speed acquired, or end of the day, what will be the speed acquired by the body? Neha, have you seen such questions? The bus numerical, do you remember?
Yeah.
You do, right? The speed acquired. So in this case, what we did, we have found out the value of the final velocity. Do you remember? In the case of the speed acquired.
Yes, sir.
So the speed acquired in this case was velocity, right? Why did we take velocity? We could have considered the speed itself, right? Why did we take that? Because in such certain instances, the speed acquired is velocity itself. Got it. So your teacher might have mentioned something, what we say, practically if you ask me, distance with respect to time graph will give speed itself, and displacement with respect to time graph, if you ask me, will give velocity. So that is why your teacher might have mentioned distance with respect to time will give speed, and displacement with respect to time graph will give velocity. But in ideal case, what are we considering? We are considering for uniform speed, straight line, distance will be equal to displacement. So in such cases, the speed and velocity will be same. So generally we will consider velocity as the slope of the distance time graph. Got it, Neha? Wherever you search.
But like, what
Yeah.
do I write in my exam?
That's why I said you can write velocity as an ideal case. Got it? So for example, if I ask you to search anywhere, research on it, what you will get? You will get the answer, the ideal case as velocity itself. Understood? There will be certain instances where it will be mentioned as speed just because practically if you are considering specifically distance with respect to time, speed displacement with respect to time, there will be differences as speed and velocity. But in ideal case or uniform motion where the distance covered with respect to time is equal, obviously you can write the slope of the distance time graph gives the velocity of a body. Clear, Neha? Is given in your textbook as well.
Yeah, okay, got it.
Did you notice, Neha? In your textbook also it is given like this itself perfectly. Take the NCRT textbook, grade 8,
I have the
grade 9,
textbook.
chapter 8 motion. You don't have the textbook or what?
I have it right now.
You have it, right? Take the graph
Yeah.
part, check it out. Yes. Now unmute Rishikesh. Hi Rishikesh, are you there? Rishikesh, is your network fine? I have tried unmuting you already, but you had some network issues, I guess. Yes, Rishikesh, go for it. What's your doubt?
Sorry, that the distance, it will be speed accurate here.
The distance is, yeah, speed by time. What's your doubt? That's it?
Yeah, I think that's
Okay, Rishikesh wants to share. Distance with respect to time will give speed, fine, fair enough. Then who wants to add something?
Muhammad Shaheen.
So Mohammad Shaheem, what's your doubt? Go for it.
Okay, so when we find the distance, we are also finding the velocity, right? Like when we are finding this speed, we are also finding the velocity, right?
Exactly. For uniform speed, or if the distance is equal to displacement, obviously we can find out the velocity as well, because speed and velocity will be the same in that case. But practically, if you ask me, the distance time graph will give speed itself, but
Okay,
in ideal case, the slope of it will give velocity. Got it?
okay, fine.
Yeah,
fine.
that is why in your textbook it might have mentioned the distance, the distance time graph will give the speed of the object, but the slope of it will give the velocity. Why? Because over here, in such cases, distance and displacement is the same. Got it?
Okay, fine.
Yes. Yes. That is the condition. That is why you guys are confused. Sir, why the velocity? Fine. So yes, who is gonna tell me the case of rest? How will we get the graph? Please do let me know. If the object is at rest, why will we have the graph straight line? What is the reason for it? Yes. Neha, you want to answer or you have a query?
Answer.
Answer.
Answer. Fine. We'll give chance to someone else. Neha is like, sir, I want to answer. You didn't give me a chance. We'll give chance to whom? Someone new. Neha is like, every day I used to answer, so it's okay. Fine. So
Nirmay.
Nirmay. Yes, Nirmay, please do let me know. In the case of a distance time graph, if the object is at rest, how will we get the graph?
Sir, it will be a straight line.
It'll be a straight line.
From the-
Guys,
from the
it's
y-axis.
supposed to be a straight line anyways.
It is parallel to x-axis.
It is parallel to the x-axis. Fine. So we are considering the x-axis. So the graph will be like this.
Yes, sir.
Sure. So
Yes, sir.
distance will be there in the x-axis, right?
Yes, sir.
Yeah, distance will be in the x-axis. Who was that? Nirmay, right?
Yeah, Nirmay.
Yeah. Nirmay, you'll write down 10 times, okay?
Sir, the x-axis is a time.
Independent variables where? Independent variables, x-axis. Dependent variable, Nirmay is like, oh god, why I have answered it. So independent variable, x-axis, dependent variable, y-axis. Please don't forget it. So Nirmay, you can make it 5. Write down real quick. Make it 5. Write it down right away. Don't consider it as a big imposition. You did a big sin. No. It's just something which will make you remember later on. You'll remember, okay, I wrote the imposition for it, so I won't forget from now on. Where is Nirmai? Ran away or what? Admit Nirmai? Hi Nirmai.
Sir, no sir, I'm here.
You're writing it, right?
Yeah, I tried it.
Yes sir.
Fine. Nirmai is like, sir, I have started already. Fine, fair enough, good. Yes.
Yes sir.
So unmute. Whom will we call? Abid. Yes, Abid. So if you are considering for an object at rest, we'll consider straight line with respect to the x-axis, right? So which quantity will take in the x-axis? Abid. Will take time in the x-axis. Why? Why, Abid? Time in seconds and distance in meters. You can simply write seconds in bracket. Why time in the x-axis and distance in the y-axis?
The formula is
Formula of what? Formula of speed. Distance and time graph will give speed. So based on the formula, we are taking time in the x-axis and distance in the y-axis. I told you, Abid, independent variables in the x-axis and dependent variables in the y-axis. How many of you remember this? Wave your hands to the camera. Wave your hands. Abid, 5 times. Go for it. Quick. Abid is like, oh sir, I have answered. Please don't give me imposition. It's not imposition at all. It's something which will make you a better person. You'll be like, yeah, this is thorough for me. Don't ask me anything. Yes, unmute Alia, right? Alia Grace on the right hand side. Right hand. This side, mirrored man. Yes. Yes, Alia Grace. Alan. Unmute Alan Grace.
Yes, sir.
Hi Alan, you just joined today or what?
No, I joined a long time ago.
Okay, you were there in my previous session, right?
Yeah.
Fine. So please let me know, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Let me know. If the motion of an object whose distance time graph is a straight line parallel to the time axis, the object will be moving. The object will be moving or rest. Which one?
It's at rest. At rest.
Object at rest. It's the same graph like this, right?
Yeah.
Yeah. So in such case, we can easily say the object is at rest. Fine. So next, we are going to go ahead with velocity time graphs. So in the meantime, Abid, are you done? Nirmay, are you done? Fine. Quick. Yes. Those who have hand raised to answer, you can lower it now. Or else I'll call your name. Fine. Mitesh, unmute Mitesh. Hi Mitesh, what's your doubt?
Sir, not doubt the last previous one you should be right. That
We have checked this out already in the previous session, these questions. We were revising, we were having a recap of the last session.
I remember. Yeah.
Fine. So Mitesh, you are not focusing. Got it? Do you feel like, yeah, I need to get my concepts more thorough? 10-15 times you want it or what? Mitesh?
No sir, I wrote it, but then I missed.
But then you were not focused.
No sir, I cut it and wrote again.
One final warning. Fine. So we'll go ahead with velocity time graphs. Let's discuss the concepts of velocity time graphs. So guys, if I'm drawing a velocity time graph, which particular quantity will I take in the x-axis? Everyone knows it. In the x-axis, will I take velocity or time? If time, y. If velocity, y. Y velocity in the y-axis, y time in the x-axis. Some of you are answering. In the x-axis time, in the y-axis velocity. Yes, because time is independent and velocity is a dependent variable, so we'll consider time in the x-axis and velocity in the y-axis. So with respect to velocity time graph, we'll consider the velocity in the y-axis, and the x-axis we'll consider the time. Please don't forget it. Y-axis, velocity, x-axis time. So please don't forget it, very important. Fine. So the basic one. So Bihar sir, can you please show me a velocity time graph? We'll consider the, if there is distance time graph, we'll go for 4 or 5. Yes. Okay, go for the third one. Yeah, velocity time graph. Yes. Can you please put me a little bit in the middle? Put the graph a little bit down, smaller. Okay. Can you put the graph a little bit smaller? So guys, can you see the graph over here? Yeah, fine. Yes. Fair enough. So over here, actually it's hitting me hard, but it's okay. So guys, over here, you can see the velocity time graph where we have considered the time in the x-axis and the velocity in the y-axis. Now, can you tell me what type of velocity time graph is it? What are we getting out of it? In the case of a velocity time graph, if the graph is a straight line parallel to the x-axis, what does it mean? The graph is parallel to the time axis. What does it mean? With respect to time, the velocity is constant. What does it mean? Yes, SA. Who was that? Yes, over there. Slide. No. Left bottom corner. Yes, left bottom corner. Yes. In the chat. Go up, SA. Go up. Yes. Who was that? Who answered first? SA. Click on it. Abid. Yes, Abid. Are you done with the imposition? Abid has hand raised, sir.
It's another Abid, not the same Abid.
Okay, it's a different Abid.
Yeah. Abdul Aziz.
Abid Abdul Aziz. So Abid Abdul Aziz, what do you think if we have a graph which is parallel to the x-axis in the case of a velocity time graph? So what type of graph would be? It would be. What do you think?
Sir, it's uniform velocity.
It's uniform velocity. Why do you think it's uniform velocity? Why?
Sir,
Because velocity is not changing with respect to time, right?
yes, sir.
Velocity is not changing with respect to time. Got it? Abid? So over here, that is why it is for uniform velocity. Over here you can see that the velocity is not changing with respect to time. You can see that the time is considered over here in the x-axis and the velocity is constant. Can you see? If you consider the values, it is same as 40 itself. Value is 40 over here. It is the same. So it is actually not changing over here. So that is why in the case of a velocity time graph, if it's a straight line parallel to the time axis, it means that it is for uniform velocity. Fine. Very good. Some of you are sharing the object is at rest. Since the velocity is not changing, the object will be at rest, right? Fine. We will check that. So object will not be displacing any particular distance, but still will it be for the object at rest, or will it be just for uniform velocity of a car? Actually the car is moving with uniform velocity. So it doesn't mean the object is at rest. The object will be at rest only in the case of distance time graph. This is not distance time graph. So in the case of distance time graph, if you have a line parallel to the x-axis, in that case distance will be constant. But over here, is the distance covered constant? No. In the case of uniform velocity, they are covering a particular distance, but the displacement or the distance covered will be the same with respect to time. So constant velocity means it doesn't mean that the object is at rest. The object won't be at rest in the case of uniform velocity of a car or an object. If you consider any object, in such cases, if you consider a particular line which is parallel to the x-axis in the case of a velocity time graph, you can't say the object is at rest. Understood? Understood, everyone? Case of a velocity time graph, if the graph is parallel to the x-axis, you can't say the object is at rest. Why? Because if it has uniform velocity always, it has a particular velocity, right? The car is moving. It is not like the distance is constant. The distance covered is not constant. The velocity is constant, which means the velocity is not changing. The body is not accelerating. It is moving in the same speed or same velocity. So this is the velocity time graph for uniform velocity. So this is an example for a velocity time graph for uniform velocity of a car. So it will be a straight line parallel. Yes, Mia, sir. You can remove the graph. So it will be a straight line parallel to the x-axis. It will be straight line parallel to the x-axis. So if you consider the velocity time graph, oh god. Yes. If you consider a velocity time graph for uniform velocity will be like this. For uniform velocity, we'll draw the graph like this. That is, the graph will be parallel to the x-axis. Fine. Who was that? Mohammed Sheikh. Yes, Mohammed Sheikh, unmute yourself. Yes.
Good morning, sir.
Is it good morning over there, Mohammed Sheikh?
No, sir. But I like to wish my teachers good morning.
Fine, got it. It'll be like something positive. So, Mohammed, please do turn on your camera before we go.
Oh, sir, you turned it off? Oh, yes, sir.
Fine. So, Mohammed, are you not aware that you need to keep your camera turned on?
Sir, it was turned on, but then I actually turned it off right now, as you told me.
Did I ask you to turn your camera off?
No, sir.
Then
Sir, I was turning my mic on, but then I turned off my camera by mistake.
got it. Fine. So you want to answer something or what? Why your hand is raised? What happened?
It was hand raised?
Yes.
No, sir, I just wanted to wish good morning.
For that you have hand raised.
Yes, sir.
So at a time when I'm discussing a particular concept, you want to raise your hands and say good morning to me?
Sir, I raised my hand before you started the chapter. You didn't see, sir.
Then once I've started the concept, why you forgot to lower it?
Sir, I forgot.
You forgot, right? So what you'll be doing?
Sir,
Yes.
the way you teach is so good that I forgot about the hand raise.
Okay. So Mohammed Sheikh,
Big fan about your teaching.
got it. So Mohammed Sheikh, what you can do is you can draw this uniform velocity time graph. Okay.
Yes, sir. Draw it, sir. Draw it. Don't
Yeah.
worry,
So
don't
how
worry.
many times you will draw? You will draw it 5 times. Got it? So that you will have a better clarity of the concept. Do it right away and show me right away. I'll give you 2 minutes. Go for it. Fine. You lower your
Sir,
hands.
you're getting the punish.
Yes, for sure. You can keep your mic on mute so that you won't forget to lower your hands in future. Yes, very nice. Yes. So, Mohammed Sheikh, draw it right away. Draw this velocity time graph for uniform velocity of an object or a car. Please do draw it 5 times real quick so that you won't forget it later and you won't forget to lower your hands. Quick, real quick. I want it right away. Fine. So unmute Mohammed Mas. Yes, Mas, what's your doubt? Go for it. Yes, on top. So Mas, can you please tilt your camera a little bit down? Yes, what's your doubt, Mas? Go for it.
First of all, good morning.
Good morning. Fine.
Secondly, can you back to the first slide? Just like 1 second.
Can you?
Can you go back to the first slide?
Previous slide.
Previous slide. Okay, you want to see the previous slide.
Fourth slide.
Which one?
The fourth one.
Four-
Hold on. 80, 86.
86. Okay. 86. Velocity time graph. Yes.
I mean 85. 85.
85. Fine. Then? Why?
No, I forgot right one.
Come again?
I forgot right one thing.
What you forgot to write?
The answer.
So, this particular question we have already discussed in the previous session. Why you didn't write it?
Yeah, I was charging.
You were?
No, I mean I was.
It's okay, it's okay. It's okay. What you can do is, please do write the question and the answer 5 times right away. Go for it, Mohammed Mas, so that you won't forget later on. You can do that, you're good to go. If there is a particular graph where the motion of an object whose distance time graph, if it gives a straight line with respect to the x-axis, this is the answer you can draw. So please don't forget to draw the graph as well, so that you'll have a better clarity of the concept. So please don't forget it. Please do draw the graph, write the answer and write the question as well. Question you can write just one single time and write the answer 5 times using the graph as well. Got it, Mohammed Mas? Got it? Fine. Yeah. You're good to go. Tilt your camera a little bit down. Take a sip of water, relax, everything will be alright. Fine? Yes. Yes. You're supposed to write the imposition right away. Go for it. Yes.
You mean like the question, the graph?
Yeah, question you can write 1 time and the answer 5 times along with the graph. Got it? Yes. Please mute Mohammed Mas. Yes. Unmute Mohammed Sheikh. Yes, Mohammed Sheikh, where's your imposition? Go for it.
Yes, sir. It was a pleasure having a punishment by you. Here's my drawing.
Yes. Show it close to the camera.
Sir, can you see?
Yes. Yes, little bit farther you can keep it. It's very close. Yeah, now I can see 5 times. Okay. But you didn't mark the velocity and time. You didn't mark
Yes, sir, it was a
velocity.
pleasure having a punishment by you, sir.
You're supposed to mark the velocity and time graph. So what you have to do? Mark the origin, mark the x-axis, mark the y-axis, mark velocity, mark time, and make it 10. Okay? Draw 5 more times again so that you won't forget it next time. So make it 10, draw 5 more graphs and mark the velocity and time in that particular graph. Not enough. 5 more times. 5 more times. Go ahead. Quick. And the heading you gave is different. You didn't give the heading of velocity time graph for uniform velocity.
I put punishment by best Manoj Kumar, sir.
No, you're not supposed to write it like that. So one last time you will get the imposition. In future, you won't be here for impositions. You will be either in the waiting room or you will be removed from the meeting. So Mohammed Sheikh is like so happy.
Sir, this is wrong, sir. This is not right, sir. This is wrong.
Yeah, call your parent. Call your parent. Yes. Okay.
Which one, sir?
Okay. Is it your dad behind?
Yes, sir.
Yeah, fine. So, sir, can you hear me? So please share it to sir.
Hello.
Yes, sir. Sir, can you hear me? Sir, can you hear me? Are you there? Yes, sir. Yes, sir. So this is the final. I'm giving him imposition in most of the sessions, and today he was having fun from the beginning. And can you please check out what you have written in the notebook? So on top of the imposition, he has written punishment by the best teacher Manoj sir. Instead of the topic, he has written like that. And when I asked him to write down the imposition, he has noted just the graph like x and y without marking the velocity, time and all. He feels like okay, he's having fun. He can make fun of the teacher, but not with me. This is the final warning which I am giving him. I hope he won't repeat it. If this is the case, we can't continue with him at least not in the waiting room, sir. So I hope you understand. Please make him understand about the seriousness of session, because when he is having fun over here, unnecessarily the valuable time of the remaining students are also losing, right? So hope you understand. Please do make him understand that to take the concepts seriously. In the beginning of session, I give some leisure time. I do interact with students so they can have fun. But when I'm explaining some core concepts, still he is having fun. Hope you're getting it.
Yeah, yeah.
Yes, sir. Yes, sir.
Okay.
Yes. Yes. So, guys, anyone? Mohammed Maz, you want to say something? Your hand is still raised. So, guys, are you able to hear? Yes, Mohammed Maz, are you done? Fine. So, everyone can hear me, right? Properly? Fine. Mohammed Maz, are you done with the imposition? Yeah, fine. So guys, this is not something that everyone can have fun in the session. This is the one you saw a live example, right? So it's not something like I will always say our admin team will contact your parents. No, luckily I got Mohammed Sheikh's parents right away during the session itself. So I've interacted with him. So in the same way, I'll be interacting with all of your parents, not directly in the session itself. I'll interact with them over call as well. And we do have a contact with your parents. I hope you're aware of it. You can have fun, but to a limit. After tolerance limit, it's not at all funny because you're wasting the valuable time of the remaining students. I do understand that. Now, when I interpreted in the issue or in the fun activity of Mohammed Sheikh, everyone was listening. What's happening? How valuable time is going, right? Do you copy that, everyone? If you agree with that, give me a thumbs up. Isn't it? To a limit, it's fine. I'll be very friendly. You can have fun. We'll be learning all the concepts in an interesting way. But after the tolerance, I'm done and dusted. Got it? Fine. Good, Mohammed Sheikh. I saw imposition. One final warning for you. Yes. In future, if you repeat it, I'll not be giving you warnings. You can sit peacefully in the waiting room or out of the meeting. Hi, Mohammed Mas. Can you please unmute yourself?
Yeah, done.
Done. Can you show me the imposition to the camera?
Sure.
Did you draw the same graph? Fine. The object is at rest. Fine. Very good. Did you learn it? If there is
Yeah.
motion of an object whose distance time graph, if it's a straight line parallel to the time axis, the object will be at rest, right? Mohammed Mas, are you clear with it?
Yes, sir.
Fine. So Mas is like, yeah, very easy. So fine. So any other doubts, we can go ahead, right? Fine. So regarding the velocity time graph, in the case of uniform velocity, it will be a straight line with respect to the x-axis. Why? Because the velocity will be constant. Don't confuse it with distance time graph. Don't think like, okay, in this case also the object will be at rest. No. In the case of uniform velocity, the object will not be at rest. The velocity will be constant. That's it. Clear, everyone? Fine. Now let's check out the case of non-uniform velocity. Yes, who was that? Rishikesh, unmute yourself.
So the government scored the science exam on 5th June.
Okay, you have exams on 5th June, then?
Then because I can leave for tuition here because I have exam
Okay.
on June.
Yeah, I do understand. Please do inform such things to our admin team, okay? Inform to our admin team. So if you have particular difficulty to join the session, you can say, yeah, exams are going on, so I won't be joining the live session, so I'll watch the recording. You can inform them. Got it, Rishikesh?
Yeah. So I'll be learning grade 7 at rest.
You're learning?
Grade 7, rest.
Rest? What rest? Object at rest? No, we are learning about uniform velocity with respect to the velocity time graph. Got it? Yeah. Mohammed Sheikh, you still have a doubt or forgot to lower your hands? Yes, unmute Mohammed Sheikh.
Yes, sir.
You still have a doubt or forgot to lower your hands?
Oh yeah, shut up, Kumar. Yes, sir. Okay.
Yeah, fine. Unmute. Who was that?
Mohammed Shaheen.
On top. Yes.
Rehan.
Rehan, what's your doubt? You want to answer or what? Mihasa, can you please
No,
take
sir.
down the name tag? Yes.
So in my school, they started with the derivation of the equations of motion with the graphical representation.
Okay.
So I'm confused in the second two, like is A2 AS equals V square minus U square and S equals UT plus 1/2 AT square. So after the session, can you explain that to me?
Yeah, regarding the derivation of the equations of motion, it's not required according to your syllabus. But if you ask me if you need it, for sure I'll derive it for you. Don't worry. Clear?
Thanks.
Fine. Either by the end of today's session or by in the beginning or the end of the next session, for sure. Clear, Rihan? Yes. Who was that? Mohammed Shahim. Mohammed Shahim, what's your doubt? Go for it.
So when it's like this, the line is parallel to time in the velocity time graph.
Yes.
Does it mean that the velocity is changing or is the velocity same?
Velocity is the same. Can you see? At the value of 40, the velocity is staying over there itself, right?
Okay, so that means that acceleration is not there, right? Like speed is same, there's no acceleration.
There is no acceleration. It is uniform velocity. Velocity is not changing.
Okay, fine, thank you.
So here, the object is not accelerating because the change in velocity is 0. So there will not be any acceleration. That is for uniform velocity. Yes, 0 acceleration. Some of you are sharing it in the chat box. Yes, who was that? Sanjit. Yes, unmute Sanjit. Hand raised. Sanjit, right? Yes, Sanjit, what's your doubt?
No doubts, sir. I wanted to answer. I just forgot to know.
Fine. So guys, please don't forget to lower your hands. Once I'm done with it, you can lower it. And once I ask questions, you can raise your hands. If I ask someone and go ahead with the next topic, you can lower it because I'll give you a chance next time, right? Fine. So over here, this is a particular example of a velocity time graph for a car moving with uniform velocity of 40 km per hour. 40 km per hour. So that is marked over here, the velocity time graph. So over here you can see that the velocity is the same. The velocity is constant. It is not changing. So that is why it is a velocity time graph for a car moving with uniform velocity or constant velocity. Now, the area enclosed. So guys, till now you guys didn't ask me this doubt. Why it is marked like a square or a rectangle? Why it is shaded as T1 and T2? We could have taken the graph just like this, right? We could have drawn the graph like this. 40 kilometers, 0, velocity and time graph, y, x and y axis. Fair enough, right? Why we have taken a particular area enclosed by it? So the area enclosed by the velocity time graph and the time axis will be equal to the magnitude of the displacement. That is, how much is the distance covered by the graph, by the object. So that is the value given by the area enclosed by this graph. Okay, the area enclosed by this graph will give the amount of displacement or the magnitude of displacement. Then the slope gives the acceleration of the body. So here, in the case of uniform velocity, do we have slope over here? Yes or no? Type yes or no in the chat box. Do we have a slope over here in the graph? Can you see any slope over here in the graph? Yes or no? No, right? Lot of no's coming up, spamming the chat box. Why? Because in the case of uniform velocity, always the graph will be a straight line parallel to the x-axis, which means there is no slope. And in the case of a velocity time graph, the slope gives the acceleration of the body. So if it doesn't have any particular slope, it means that the body is not accelerating. The acceleration is 0. Clear, everyone? Clear? Fine. So where is Neha? Neha, are you clear with the velocity time graph slope? The slope of the velocity time graph gives the acceleration. Are you clear with that concept? It is Neha. Neha had a confusion with respect to distance time graph. Now, are you clear with the concept of velocity time graph slope? Unmute Neha.
Yes, I got that.
Fine. So Neha, you don't offend your teacher. Don't say, sir, teacher, my tutor told the distance and time won't give speed. It will give speed, but theoretically, if you are considering in ideal case, distance and displacement will be equal, right? So you have to mention it. Don't say, ma'am or sir, you are wrong. My 90 plus tutor said that. Yeah, you got a clarity about it, right?
Yeah.
Unmute Chris. Hi Chris. Chris, right?
Yeah, Crystal.
Yes, Chris.
Yes, sir.
You want that?
I just got messed up.
With the
I
slope?
got confused, sir. Yeah.
Yeah, fine. So, can you please keep yourself unmuted? Yes. So,
There are my brothers over here, so they will make really noise. That's
got it. Fine. So,
So
Christo.
can I keep unmuted?
Yeah. You can mute yourself. Fine. I understand. So, Christo or Chris, what is acceleration? It is the change in velocity. With respect to time, right? Guys, do you remember the equation of acceleration? A is equal to V minus U divided by T. Do you remember it? You guys do remember it, right? So in this case, what we'll be doing? We'll be considering the change in velocity. Either the velocity will be increasing or the velocity will be decreasing. So, in the case of a velocity time graph, so let's consider a small graph over here, guys. This is a graph, okay? This is not some small centipede. So, if the velocity is increasing in the velocity time graph, it will be like this, right? And if the velocity is decreasing, let's consider it will be like this, right? Fine. So, over here you can see a slope. There is a slope over here. Slope is there, and over here also slope is there. So, if the velocity is increasing, there is a change in velocity. If the velocity is decreasing, there is a change in velocity. So in both the cases, we are considering the values with respect to time, right? So change in velocity with respect to time, what is it? It is the acceleration. That is why the slope of the velocity time graph gives acceleration. And mute Chris. Let me know, please be honest. Did you get the concept?
I got that. And what is that box over there which is called as AT?
So over here we are considering two instances of time, that is time t1 and t2. For example, here we have values, right? 1, 2, 3, 4. So for example, if we are considering two values t1 and t2, so at this particular time instance, what is the amount of distance covered by the object which we are considering? So as to understand the distance covered by the object, what we'll be doing? We'll be finding out the area enclosed by this graph. Understood? So we are not taking the entire graph. We are taking only these two instances of t1 and t2. At this particular time instance, what is the area? What is the distance or the displacement covered by the object? So you'll have a better clarity of this when we solve some numerical problems. Got it? So as of now, you have to understand we are just taking two time instances. So this area enclosed by the velocity time graph and the time axis will be equal to the magnitude of the displacement or the displacement by the object. Clear, Chris? Give me a thumbs up. Fine. Everyone wrote this? Please do write it down. You don't have to write this. This is just an example, right? So if you're drawing this example with values, you can write down, or else just draw the general graph without values. Just write velocity and time, velocity in the y-axis and time in the x-axis, and you have to write the graph for uniform velocity with respect to the velocity time graph. And please don't forget to mention this, write this down, this is important. That is, the area enclosed by the velocity time graph and the time axis will be equal to the magnitude of the displacement. The slope gives the acceleration of the body. So draw the graph, write down these 2 points, and if you are noting down the values, please do note down the values as well, quick. Once you're done, type done in the chat box. Yes, Mihir sir, can you please make me invisible for a minute? Once you're done, type done. Most of you might have done already. Yes, there you go. There we go, everyone done, I guess. Fine. So let's go ahead. So velocity time graph for a car moving with uniform acceleration. We have considered uniform velocity. Okay, now we are going to discuss about uniform acceleration. Yes, Ayman, what's your doubt? Hi Ayman, what's your doubt? Go for it.
Yes, sir. So I have a doubt. If a velocity time graph is just like like parallel to the x-axis, we know it's uniform velocity graph. But when the velocity time graph, where the acceleration is uniform motion, then will it be non-uniform?
Acceleration in uniform motion.
I like uniform acceleration.
Uniform acceleration. Then
Will the graph be non-velocity graph, non-uniform velocity graph?
for uniform acceleration it will not be non-uniform, right? So for example, for uniform acceleration, how will the velocity time graph will look like?
It will be parallel to the x-axis.
It will look like this, right?
The distance can be.
So for velocity time graph, for uniform acceleration, the velocity will be increasing with respect to time, right? So it will be uniform acceleration.
I'm talking about the non-uniform velocities, right? Like
Non-uniform velocity. So we are considering velocity time graph. Okay, velocity time graph. Then
I was asking, so like just the graph we draw right now.
okay, we can consider like this: non-uniform velocity. Velocity is changing. Then
So why is the uniform acceleration not non-velocity? Because it's not constant with time, right?
that is for distance. It is velocity. You're thinking in an angle of distance time graph. So the parameter on the y-axis or the quantity on the y-axis is actually velocity, not distance. That is why you're confused. So yeah, you're saying yeah. Come again.
The thing is, okay, let's take. I actually, our teacher made us wrote this today. Can you see? Let me remove the blur.
Yeah, remove the background blur.
Yes. I think.
Remove the background blur.
Yes.
Yes.
So for number 4, can you see?
Yes, I can see. Uniformly accelerated. Yes, it's perfect.
Accelerated. So
Yes.
can we take this as non-uniform velocity?
For non-uniform velocity, yes, you can take it for sure. Because the velocity is changing.
Yeah, exactly. That's
Okay, we are asking that. Can we take a uniformly accelerated motions graph for non-uniform velocity? For sure, you can take that. Got it? Fine. So for everyone, those who didn't get what Ayman was asking if we are considering a particular velocity time graph for uniform acceleration. We are considering a graph for uniform acceleration, which means with respect to velocity, the time is increasing. With respect to the time consumed, the velocity is increasing in equal intervals of time. So if this is the graph for uniform acceleration, can we consider this particular graph for non-uniform velocity? Can we consider this graph for non-uniform velocity? Say yes or no. Guys, in your chat box type yes or no. Let me see how your thoughts. Yes or no, quick. Only some no's and some yeses coming up. Can we take this graph for non-uniform velocity as well? Some are sharing no, some are saying yes. We can take this uniform acceleration graph for non-uniform velocity. Why? Because the velocity is changing. The velocity is not constant, it is not uniform, it is changing. Got it? If the velocity is same with respect to the time consumed, it is for uniform velocity. But if the velocity is changing with respect to time, it will not be uniform. So we can consider it for non-uniform velocity as well. So this is an example for uniform acceleration. Please do note it down. Yes, because if it is uniform acceleration, then there will be different final and initial velocity. So there will be a change in velocity. Very good. Who shared that? Neha Das. Fine. Yeah, there's others like, sir, regarding velocity time graph, I have better clarity of the concept. Don't make me confused, I know it. Fine. Unmute, who was that?
Mehrab.
Hi Marab, unmute Marab. Where are you? Where are you, Marab?
Yes, sir.
Yes, Marab, what's your doubt? Go for it.
So can you go to the previous slide?
Yes, for sure. Why?
So yeah, you said like for finding the magnitude, like something I forgot.
For the magnitude of displacement, we are considering the area enclosed by it. So once we solve some numerical with respect to that, we will have better clarity. Why?
So how do you find that area?
So over here, if it's a rectangle, you have to use the equation for the area of a rectangle. What is the equation for an area of a rectangle? Do you remember mathematics?
To L into B.
L into B, right? Length into breadth.
Yes.
Yeah. So we'll consider that.
Nothing is written there except the velocity and time.
That's when we will solve, right? That's when we solve some numericals. As of now, what you have to understand, the area enclosed by the velocity time graph will give displacement. That is the only thing you have to get reminded of you or to note it down. Clear?
Yes.
In general terms, we won't say for area of rectangle we'll consider L into B. What if we are considering a trapezium? It depends on the time instant we are considering, right? Understood? Yes.
Yes, sir.
So initially, for example, yeah, I'll show you an example, Madam. So if we are considering 4 instances, that is, at the time interval or at the distance 0, we'll consider 2 time intervals, t1 and t2. And at a velocity of 40, what if we are considering a time interval of t3 and t4? Here also you have time intervals, right? So the area enclosed by it will not be a rectangle, it will be a trapezium like structure. So you have to find out the area of a trapezium. Got it, Mara? Clear? So once we solve some numericals, you will have better clarity of it.
I'm still confused about the uniform, like how it
Uniform acceleration or uniform velocity?
velocity.
Why you didn't ask me? Before I go ahead with uniform acceleration, no, I asked everyone. Why are always like, once I reach the other end, Mara will be like, sir, in the beginning I had it out. Why you didn't ask me when I was explaining this?
I raised my hand, but you didn't unmute.
If I didn't call you, you can drop it down chat box, right? Sir, doubt or ma'am, doubt. Why you didn't ask Marin, ma'am? Mara. There was no hand raises, right? Mara, you didn't hand raise, don't lie. I was noticing, I was calling each and every hand raise. Should I show you the recording, Mara? Should I show you the recording?
Yes, sir, like before you disappeared.
Before I disappeared, Mara. So when I was asking, when I disappeared, what I said, guys, note it down. Once you're done, let me know. Anyways, so Mara, what is your doubt regarding uniform velocity? Go for it.
So why is it straight? I'm still confused.
Confused about what?
Like how is it like straight?
Okay, why the velocity time graph is straight in the case of uniform velocity, right?
Yes, sir.
Yes. So, in the velocity time graph, madam, so consider the time in the x-axis. You know why we are considering the time in the x-axis, right?
Yeah.
Why?
Independent variable.
Independent variable. So, dependent variables, we are, oh god, this so curve. So, it is supposed to be straight. Anyways, I'll draw it again. Fine. So bear with me. You guys understood, right? It's supposed to be straight. Fine. So, madam, what are we doing? We are considering the velocity and time, right? Velocity in the x-axis and time in the y-axis. Okay, time in the x-axis and velocity in the y-axis. So, for example, in the case of distance time graph, what happened? When we are considering an object moving like this, it is covering a particular distance with respect to time. Okay, So do you know what is the difference between velocity and distance or displacement? Velocity is the distance with respect to time or displacement with respect to time. Do you know that velocity is displacement by time? Are you aware of it? You are, right? So if you draw a graph like this, velocity will be increasing with respect to time, right? Will it be a same value? Will the velocity be a same value? Let's assume 10, 20, 30, 40, 50 and all. Will it be a same value? Consider the graph over here. So if you are taking the values, will it be a same value? No, right? The velocity is changing with respect to time. Can you see Mara? Unmute Mara. Fine. So is it uniform velocity? No, right? The velocity is changing with respect to time. Over here, can you see?
Yes, sir.
Fine. So when we are considering a graph which is parallel to the time axis, over here, if you are considering values 0, 10, 30, 40, 50 and all. So consider 10 time in minutes, okay, 10 minute, 20 minute, 30 minute, 40 minutes and all. So when an object, if an object is moving, let's consider the star as the object. If this star is moving like this with same amount of velocity, that is the displacement with respect to time is same. Okay, if it's covering 10 meters in the first minute, 10 meters in the second minute, like that, if it covers. So after 40 minutes, it'll be covering a particular distance, right? But the velocity, that is distance covered with respect to time, will be same, or the displacement with respect to time will be the same. That is, the velocity value is 30 itself over here. Can you see? There is no change in this value, right? Is it increasing or decreasing? No, right? Not increasing, not decreasing. It is constant, it is moving like this. So which means velocity is uniform, not changing. So that is why the line which is parallel to the time axis is for uniform velocity. Merab, understood?
So velocity is like displacement with direction, right?
Velocity is not displacement with direction. Velocity is speed with direction.
Yeah, speed with direction. That's why I was curious.
Yeah. Now you understood?
Thank you for having that.
Come again? Again you are confused or you got it now?
Yes, sir, I got it.
Please be honest. Unmute Merab.
Yes, sir, I got it.
You got it. Velocity is not displacement with direction, it is speed with direction. Yeah, it is speed with direction. So here, in this case, you can see that the velocity is constant, it is not changing, it is at 30 itself. Got it? That is why a line which is parallel to the time axis will be for uniform velocity. Got it, Merab?
Yes.
Fine.
Thank you.
Yeah. So velocity time graph for a car. So Merab, one thing you have to note down when I discuss something, when I ask you, so guys, is there any doubt? Can I go ahead? You can say, sir, I have a doubt. Not when I reach the end. Got it? Fine. So velocity time graph for a car moving with uniform accelerations is shown over here. So guys, please don't get confused with the area enclosed over here. So we'll discuss about the area enclosed. So if you have such an area, what you will do? How you will consider? It will be tough for you, right? So what we'll be doing? First we will consider this triangle. Then we will consider this rectangle. Got it? So that we will get the area enclosed. So area enclosed in the case of a velocity time graph will give acceleration, right? So this is for velocity time graph for a car moving with uniform acceleration. So we have discussed it already. So in the case of non-uniform acceleration, what will happen? In case of non-uniform acceleration, velocity will be either increasing or it will decrease. It will increase again, it will decrease. So this is how you will observe the velocity time graph for a car moving with non-uniform acceleration. Please do note it down. Fine. SN, who was that? Unmute Eric. Eric, what's your doubt?
I have had my hand raised for too long now.
Fine. So Eric is like, sir, you didn't address my query. Guys, if I'm not addressing it, you can drop it down chat box. That is why you have that option. Mary ma'am is like jobless, sir. Students are not asking me. I'm just responding or unmuting. Yes, Eric, go for it.
I still, like, when you were explaining velocity timer first, that time I didn't understand. So I raised my hand to ask you what, like, can you explain 1 minute? Now, can you explain velocity timer one more time?
So in which context are you confused? Why the parallel line to the time axis is for uniform velocity? Is that what you are confused with?
That entire thing. I just want to clear up something. That parallel line is just the car in a constant speed, in the same speed continuously for a distance. That's it, right?
Exactly. It is covering, it is having same displacement. For example, if you are considering a path, okay? So consider a path over here. So 5 meters, 5 meters, 5 meters. So if a car is moving this same distance in same interval of time, consider 5 seconds, 5 seconds, 5 seconds. So over here the car is covering each particular amount of distance in same interval of time. So the displacement with respect to time is same. That means the velocity will be the same. So that doesn't mean that the car is at rest. The car is moving already, but the velocity with respect to time will be the same. That which means the displacement with respect to time is same. What is velocity? Is displacement with respect to time. So the distance covered by the car with respect to time will be the same. So that is the velocity time graph, which is parallel to the time axis, is for constant velocity. Over here, if the velocity is changing, will it cover equal distance? No, right? The distance covered with respect to time will be changing. Understood, Eric?
Yes, that's basically non-uniform. When both displacement and time
is changing, it'll be the velocity time graph will not be a straight line. It'll be like this or it'll be like this. Got it?
So if it's going upwards like that, and the one that you've shown just now, both of them are not uniform?
If it goes like this,
yeah.
If it goes like this, what happens? What happens if it goes like this? 5 meters.
0 to, is going from 0 and
5 meters, 5 meters. So if it goes from 0 to, for example, if the velocity increases from 5 meter per second, okay, don't write like this, but just for the space reference, I'm writing it like this. So if the velocity goes from 5 to 10 meter per second, imagine, with respect to 10 minutes, so this is 5 minutes. So in 10 minutes, the velocity increases to 10 meter per second. Will it cover same 5 meters? No, right? In the next second, it will cover 10 meters, right? So the first second, it covers 5 meters, and the next second, it will cover 10 meters.
Okay.
So will it be uniform velocity?
Non-uniform.
Non-uniform velocity, right? But the graph will be a straight line like this, but not parallel to time axis. Understood?
Okay.
Eric?
Okay. As long as the line is parallel to the time x-axis, then it is considered uniform.
Uniform, yes. But in distance time graph, that makes you confused. In distance time graph, we are considering the distance. In velocity time graph, we are considering velocity. That is the difference.
Yeah, that part really didn't confuse me.
That is the yeah, I do understand. When I was in 9th grade, even I was confused with this concept. Now is it clear for you? Please be honest. Yeah.
Yes.
Fine. Unmute Abid. Yes, Abid, what's your doubt? Go for it.
If when an object is moving to then it might
I can't hear you, Abid. Your voice is breaking.
maybe network.
Yeah, now I'll try speaking a little bit louder.
If an object is moving and it decides to go to different value, so how is it translated?
Can you please type it down, Abid? Maybe your network or mic. I'm not able to hear you. Please do write down. Yes, sir. For this example, we can use, who was that? We can use the trapezium formula, right? Yes, you can use the trapezium formula as well. But this is not a perfect trapezium, right? Still, you can use it. But for a convenience, what we'll do, we'll consider the triangle and rectangle. Anyways, you can consider the trapezium formula as well. Yes, unmute Chris. What's your doubt, Chris?
No, sir, I think I messed up with that.
Which one? Chris?
A non-uniform acceleration.
Non-uniform acceleration. This one, right?
The whole thing.
Okay, this the concept of non-uniform acceleration you're confused. Fine. Yes, Chris. In the case of uniform acceleration, what happens? The velocity, the change in velocity with respect to time will be a constant value. So for example, if I am taking a velocity time graph, okay, time and velocity, okay, this is velocity and this is time. So if I am considering 10 meter per second, 20 meter per second, 30 meter per second, like that if it goes on, and with respect to time, 10 minutes, okay, per second, right, 10 seconds, 5 seconds, okay, not 5, 15, right, 20 seconds, 25 seconds, so it goes on like this. So if the object is covering equal velocity with respect to time, so that is the velocity is increasing equally, that is initially it has 10 meter per second velocity, that is it is covering 10 meters in 1 second, and the next second if it's covering 20 meters in 1 second, it is accelerating, right, it is increasing its speed, and the next second and in the 20th second it is increasing its speed to 30 meter per second. Imagine this graph is a straight line. Okay, so the level of acceleration is constant, that is 10 meters in the first second, 20 meters in the next second, 30 meters in the next second, which means the car is constantly accelerating, that means uniformly accelerating. Got it? So unmute Chris, did you understand the uniformly accelerated motion? Is it clear?
Yeah, that I understand.
This is clear, right?
It's
Fine.
clear.
Now when we consider the non-uniformly accelerated motion, if we consider the velocity and time, the first second, if it's accelerating to a particular value, that is 10 meter per second, and the second second, next second, if it decelerates to a particular value, the velocity is decreasing. So is it constantly accelerating? No, right? It decelerates, it slows down, the vehicle slows down. Again the vehicle accelerates to a particular value, again it slows down. Will it be a constant acceleration? No, right? It is, the acceleration is non-uniform, which means sometimes accelerates, sometimes decelerates. Got it? Now we understood the difference between uniformly accelerated and non-uniformly accelerated, which means the change in velocity is not constant. Fine. Thank you, Chris. Yes. Who has some query? Yes. Who was that? Abid. Abid wants to share, if the object decided to go in negative value, then how will the graphical representation will be? Deceleration, retardation. This is how the graph will be. If the object has deceleration or retardation, that is the object if it goes in the opposite direction. So this is how the graph will look like for deceleration. Clear, Abid? Fine. Abid gave me a thumbs up. So I hope it's clear for you. So guys, those who have done with the non-uniformly accelerated motion, once you're done with this, please do draw this. The graph for retardation. Please do note it down real quick. Some of you are sharing, sir, quiz time, exam time, don't worry. Yes. Mia sir, can you please share the graph for retardation? I'll let you know the graph for retardation with a better clarity. Yes, the same graph over here. Yes. So guys, yes, Mihar sir. Can you put me in the middle? Yes. Can you put me in the middle? Yes. Just a second guys, a little bit left, some more. Yes. So guys, over here, in the x-axis we are considering some particular time intervals 1, 2, 3, 4, 5 and 6. And in the y-axis we are considering the velocity, that is 10, 20, 30, it goes on like this. So for example, if there is an object if it has a velocity of 20 meter per second, over here can you see 20 meter per second, you can see, right? So at this particular instant, okay, the car, if I'm driving the car, I decided to slow down, okay, I decided to slow down my vehicle or the car, what will happen? The velocity will get reduced, right? Can you see this value? So at the first second, okay, at the first second, the car will slow down to a particular value, so that will be between 10 and 20. So just let's assume it as 18. So speed of the car reduces to 18 meter per second. Okay. And the next second, I decided to slow down my car a little bit more, so it will be 15. Let's consider it as 15. So 15 meter per second in the next second or second. So what happens? The speed of my car reduces, which means the acceleration is also reducing accordingly. Got it? The acceleration is also reducing accordingly. So this means the acceleration in the opposite direction. What is acceleration in the opposite direction? As you see over here, it is none other than retardation or deceleration. Got the concept, everyone? Those who got the concept, nod your head like a puppet. Yes sir, we got it. Those who have a doubt, please do raise your hands. Unmute Neha.
Yes, sir. So, I have a doubt in non-uniform acceleration.
Okay.
Over here, like for uniform acceleration and everything, you can find the displacement, right? The area below the slope
Yes.
is the displacement.
Yes.
But over here in non-uniform acceleration, how do you find the displacement?
We have to take each instances. Miyasa, can you please put the graph for non-uniform acceleration? The jumbled, yes, this one. Yes. So Neha, over here for non-uniform acceleration, if we have to find out the displacement, will it be like the entire graph? No, right? We'll take a time instance. So for example, if you are taking a time instance from 0 to 8 till this value, if I take this instance, will it be a triangle? If I take this, will it be a triangle? Neha, are you there?
Yeah.
This particular instance will be a triangle, right? So I'll find the area of the triangle so that I'll get the displacement of it. If I find the area of a triangle, I'll get the side, right? So I'll get the displacement.
Yeah.
Fine. So if I have to find out the instance from 0 to 10, suppose. So what will happen? This figure will be like this. So either I can consider it as a trapezium, or I'll half it, like it'll be like one trapezium and one triangle. So like that I can find out. So it's just that the number of steps will increase, but still we can find it out, but it'll be very complex. That's it. If it's a curved line and all, it'll be tough for us to find out the area enclosed by it. But anyways, yeah, in ideal case what we'll be doing, we'll be considering the solid values, but in non-uniformly accelerated motion, for each instance we have to calculate. That is the only thing which we can do to find out the displacement using the non-uniformly accelerated motions graph. Neha.
So these kind of questions won't come in exam.
Won't come. It won't come. Because it's tough, right? It's practically very difficult to find out the area enclosed by a non-uniformly accelerated motion. If it's a precise graph like this, you'll be asked to find out the displacement at a particular instance, such as 0 to 8 or 0 to 4, like that. So that you have to find the area enclosed by it, so that you can take that particular instance itself, right? So it will not be tough. But if it's asked to find out for a greater value of time or greater unit, what we'll be doing will be tough for you, so you won't get such questions. Don't worry. Got it clear, Neha? Clear? Your face looks confused. Fine. No. Okay, anyone else? Any doubts, queries, concerns? Yes. Abid, any doubt? Fine. Unmute. Who was that? Joel, go for it. I know some of you are asking, sir, exam time. Yes, I'll give you time. Don't worry. First, we'll have a clarity of the concept. Then we'll go to the exam. Yes.
Good evening, sir.
Good evening.
Sir, it is about the retardation. You were answering Abid's question, right?
Yes.
Yes,
sir.
He asked
the graph for retardation.
Yeah.
Yes.
So when he was asking about the negative value, you showed the graph of retardation, but in this one it's deacceleration, right? So like,
Deceleration.
it's not, yeah, deceleration. It's actually not like going negative. You're just decreasing like the number. So I don't.
He meant that only. The negative, the acceleration, the opposite direction. That is what he meant about negative. Anyways, yeah, you won't go to the underground, right? The maximum you can go is zero for acceleration. How will you go? Yeah, think about it, Jewel. Imagine you have a value of acceleration as minus 10 meter per second square. What does that mean? Acceleration negative 10 meter per second square. We have solved a lot of numericals in equations of motion. Negative 10 meter per second square means what? Acceleration in the opposite direction. So that is velocity will be 10 meter per second square in the negative direction, which means deceleration. It won't be below this graph. It won't go down the graph. Understood, Joel?
So sir, this retardation graph is not only for, it's for any moving object, right? Any moving, like anything that's going down a slope, to be precise.
Actually, this slope is for retardation, acceleration in the opposite direction. Not the object is going down a slope. No. These are the values taken with respect to the object moving in the, for example, if a car moves with 50 meter per second, okay, which means it is covering 10 kilometers in 1 hour, okay, not meter per second, we can consider kilometer per hour, okay, we'll have a better clarity. So 50 kilometer per hour initially, so you'll be covering 50 kilometers in how many hours? 1 hour. And if it decelerates, if it goes to 30 kilometer per hour, which means the acceleration is reduced, so it'll not only be covering 30 kilometers in 1 hour. So in this case, the velocity time graph will be like this. So initially 50, then next case 30. So the value will be like this, but the time scale will be 1 hour itself. Each interval will be 1 hour itself. So the graph will go down. That is negative acceleration. The acceleration value will, oh god, Mihar sir, can you please take down the graph over here. 1 second, Jewel. Yes. So if you are considering 50 and 30, can you see? The first hour, what will be doing? Okay, you'll be covering 50. Okay, let's consider the graph like this. So we'll have a particular value that is 50. Okay, at the first hour, at the first value. Then it will go down with respect to the coming hours. So it will be 30. So in the next instance, for example, we'll consider 15 and go down like this. So that will be for retardation or deceleration, Jewel. So acceleration, the negative direction will not go down the graph. Negative value means
sir, I was just wondering like between like a moving object like or any object. That was a confusion, but now it's
any object, but if the acceleration is reducing, if the velocity value is reducing, it is deceleration. That is the acceleration in the negative direction or opposite direction. Understood?
Yes, sir. Thank you. Thank you so much.
Fine. Then who else? Yes, Mohammed. Who was that? Okay, Abhinav, right? Yeah, on left corner. Yes. Abhineet. Yes, Abhineet. Merin ma'am, please check out the hand races. Yes, Abhineet.
Sir, I wanted to ask you if you could go back to the previous slide. I was noting it down.
This one.
No, sir, before that. I did that.
For uniformly accelerated motion.
Yeah.
Regarding the area enclosed, once we solve the numericals, you will have a clarity. Let me know, did you understand for uniform acceleration why the velocity is increasing with respect to time?
Yeah, that's what I doubts I was.
Well, what is acceleration? It is the change in velocity with respect to time, right?
Yes, sir.
So, if the velocity is increasing, for example, if a particular car is moving with 20 meter per second in the first 10 minutes, if it's increasing to 40 meter per second in the next 10 minutes, will it be the same amount of acceleration? That is, the acceleration with respect to time will be the same, right? 10 meter per second first, then 10 in the next minute or next hour, it will be the same, right?
Yeah.
Which means the vehicle is accelerating in the same way. same amount of
Same.
time, which means it is uniform acceleration.
Uniform acceleration.
Yeah.
Yes, sir.
Got it?
Got it, sir. Got it.
Yeah. Unmute Mehrab. Yes, Mehrab, what's your doubt?
Lower the hand.
Lower the hand. Fine. Mehrab, is it clear?
Fine. No doubt.
Yes, Mehrab.
You can find the area of this also.
Come again?
Is it possible to find the area of this?
Area, I told you. Who asked that? Neha asked, right? When we are considering the area of non-uniformly accelerated motion, we'll consider any particular time instance. They won't ask the entire area of the graph. So if there is a question, it will be given, a particular time instance will be given. Don't worry, for non-uniformly accelerated motion, you won't be asked to find out the area of it, for sure. If it's asked, you will get such instances from 0 to 5, 6 or something. So you'll be asked to find out the area so that you can draw a triangle. Or else, if it's from 0 to 10, you can draw a trapezium and triangle as well so that you'll get the area. Understood?
So they will say to, in the exam they will ask you about this.
No, they won't. They won't. If they ask, they won't ask the entire graph. They'll take a particular instance, then they'll ask. Without a particular instance, in non-uniform acceleration, you can't do that. In uniform, you're asking. Okay, you are asking about uniform. In uniform, you can easily take it. Easy.
They will ask, right?
Yeah, they will ask. Clear?
The idea it won't come, like it's just
No.
for
Yeah, chances are less, but still, we'll solve some numerical so that you'll have better clarity. Clear? Yeah. So in general, in exercise questions and all, you might have not noticed it, but still, certain questions will come. We'll solve some numericals, anyways. So any doubts before we go to the exam time? No, right? Unmute Rehan. Where is Rehan? Rehan, can you please raise your hand? Rehan, ask me about the derivation of equations of motion. Yes. Rehan?
Yes, sir.
Yeah, equations of motion regarding the derivation of s is equal to ut plus half at square, right? Or v is equal to u plus at. Which
So the
equation?
second one and the third one.
Second one and the third one. 2as is equal to v square minus u square. S is equal to ut plus half at square. So that is deleted according to your syllabus. Why do you want that?
So it's taught in a class.
Okay, so to have a clarity of the equation. So
Yes, sir. It might
yeah, but it was not clear for from your school, right?
No, sir. I wasn't there that class since I had to go for an event that day, so I wasn't there for that class. So I just
Okay, okay, fine. So you need to know how we derived that equation, right?
yes, sir.
Fine. Should we do it today or tomorrow? Or for the next session?
So we can do this class. For the next week.
Yeah, I just asked because we are already late, right? We are already 10 minutes extra, and after the exam time we'll be having some, what we say, time limitations. So that is why we can't extend. I hope you understand. So I told you, in the end, today if we get time, we'll do it, or else in the next session, right? Today we are already running late, so we won't be able to do it today. I'll do it in the next session. Is that okay? So what is the what is the only thing which you have to refer by the next session is, do remember the position time graph or the velocity time graph is given in your textbook. So there is a position time graph given in your textbook which has divided the area with respect to the rectangle and a triangle which we are considering. Okay? So the area enclosed by the triangle and the rectangle will consider, so they will be marked as O, A, B, C, like that. Okay? So we'll be considering the area of the triangle first, then we'll be considering the area of the rectangle. So if we do that, or if we add the area of the triangle or the rectangle or the trapezium, we'll get the area enclosed by it, and using that we'll derive the equation for s is equal to ut plus half at square, and like that we'll derive the equation for 2as is equal to v square minus u square. For v square minus u square, we'll consider the velocity time graph. So in that, we'll consider the velocity time relation, and s is equal to ut plus half at square is distance, right? So in that, we'll consider the position time relation. so that you'll get the equation. But according to your syllabus, for exams it won't come. But for you to have clarity, I'll help you out. Understood? Yeah. So please do refer that and come, so that it will be easy for me to make you understand. Clear? Rehan? Yeah. So submit your responses, guys, real quick. Those who are done with the exam, type done. Quick. Real quick. Finished, right? Everyone done? Those who are done, give me a thumbs up. Or wave your hands to the camera. Let me see your responses. Sir, I'm done. You can go ahead. Fine. So guys, we are noting down how many of you are doing the exam in the right time. How many of you are consuming a lot of time. Some of you will be doing it when we are discussing the answers. Not a lot. Our admin team is watching. Our student coordinators team is watching it. So velocity time graph for a uniform velocity of a car will be first, second, third, fourth. Everyone shows the victory sign, as that is a straight line parallel to the x-axis. Now, the area enclosed by the velocity time graph and the time axis will be equal to the magnitude of displacement. Is it true or false? True or false? Is true for sure. You know it, right? Area enclosed by velocity time graph, it gives the magnitude of displacement. Now, the next question. The slope of the velocity time graph gives the dash of the body. Velocity time graph, Neha will answer. Neha, which option? Option 1, 2, 3, 4. Which one? Show it to the camera. Don't unmute. Okay. Acceleration for sure. That is, for velocity time graph, it is acceleration. For uniform speed, a graph of distance traveled against time is not a straight line. Is it just straight line? For uniform speed, distance traveled against time will be a straight line, right? Straight line like this or straight line like this? Like this or like this? Like this, right? Like an aeroplane. So it is false. It is mentioned not a straight line. Actually, it's a straight line. Now, the independent variables are taken on the y-axis. Bro, independent variables are taken on the x-axis. Dependent variables are taken on the y-axis. So statement is false. So second option is the right answer. Fine. Any doubts before we wind up? Alright. Rehan, please remind me in the next session. Please don't, like if I forget in the next session regarding the derivation of the equations of motion which you want, you can, please do remind me, sir, we need to derive it, so that I'll do it at the end of session. Yes, no homework. You have to learn, you have to revise the graphs. Please don't forget it. Yes, who was that? Who have a doubt in the second question? SA, who was that? Yes. Abid, what's your doubt in the second question?
I think I got it wrong.
You got it wrong. You understood, right? Why velocity time graph, magnitude of displacement? We have discussed it already. Can you see? Velocity time graph, area enclosed by the velocity time graph will be equal to the magnitude of displacement. Abid. Clear?
Okay.
Yeah.
Yes, sir.
Yeah. Anyone, any doubt? No, right? If all the concepts which we have discussed today is clear for you, I won't ask crystal clear. You need to have a crystal clear clarity of it. When you will have it? Once you revise it. Once we solve more numericals regarding it, once you revise it, you will have a clarity of it. Got it? Yes, unmute Mehrab.
Yes, sir.
What did you ask? No, sir. No, sir, for what? Can you explain?
Sir, no doubts.
You typed it before or what?
Yeah.
Okay, now first you try to revise. Then if you have any doubt, you can ask. Got it?
Sir, can you explain next class exercise in the textbook?
Yeah, once we finish the chapter, once we finish the concept, we'll discuss the questions as well. Or regarding the graphs, I'll add some questions from the exercises as well. Don't worry. Yeah. Fine. So that's all for today, guys. Please do revise everything we have learned. Don't forget to do that. Stay healthy, stay happy. Thank you and have a nice day. Bye.